Just finished how to solve systems of linear equations by elimination, by the addition method. Another way to do it besides graphing and the addition or the elimination method was called the substitution method. This method works really well if one of the variables is already all by itself, as one of the variables is already isolated. In this case, we've got two linear equations, and y is isolated in both of them. So here's how the substitution method works. If we know that y equals 8x plus 46, if we know that y is the same as 8x plus 46, wherever we see a y, we can replace it with 8x plus 46. Now, if you did that in the first equation here, you'd end up with 8x plus 46 equals 8x plus 46, which is redundant, and so that doesn't really matter. But if we take that y equals 8x plus 46 and we replace this y with 8x plus 46, so we substitute. Instead of writing y here, we're going to write whatever y equals. We're going to get one equation with one unknown. We already know that y is the same as 8x plus 46, so we're just substituting 8x plus 46 for y in the second equation. Now we solve for x. You minus 8x from both sides, you minus 36 from both sides, divide by 2, we get that x equals 5. So we've solved for x. Remember that that's not the end. We still have to figure out what y is, but we know what x is. X is 5. So in either equation, it doesn't matter. I think I'm going to choose the first one here. Oh, nope, I chose the second one. Doesn't matter. We can replace x with 5. We can resubstitute now 5 in for x. 10 times 5 is 50 plus 36. It's going to give us 86. In fact, if you remember back to the other video, the very first problem was about somebody, I forget their name, and they had a dilemma about which cell phone company they should go with. And this was the same problem. We figured out that if they used 5 gigabytes, then the price was the exact same, no matter which plan they went with. And so the graphing gave us the same solution. Graphing gave us x equals 5, y equals $86. And the substitution method gives us the same result as well. After 5 gigabytes, it was $86 for both of them. So there's the solution there. Same idea here. We have one of the variables isolated. X is isolated. X is all by itself. The other one is not, but that's okay. We only need to have one variable isolated to use this method. So if x equals y minus 8, wherever I see an x, I can replace it with y minus 8. Here's an x. So we're going to replace x with y minus 8. We end up with this. Now be careful here. When you're substituting and when you're replacing, parentheses are important because it's -2 times whatever x is. X is y minus 8. So it's -2 times y minus 8. We have to distribute through the parentheses, and then we can combine like terms. -2y minus 2y is -4y, and we can solve for y from there. Add 4y to both sides, divide by 4. We get that y would have to be 4. So we're halfway there. We've solved for y in this system. I have this equation here that says x is the same as y minus 8. Now, it technically doesn't matter which equation you replace y for. However, if we're trying to solve for x now, might as well use the one where x is already by itself. So we've got this equation. We know that y is 4. X would have to be -4. So our solution to this system of linear equations, -4, 4. So that's how you use substitution to solve for the given system. Either isolate one of the variables and then go from there, or if one of the variables is already isolated, use that one. I've got two problems here. I'd like you to use either method, either substitution method or the elimination method, and try and solve these two equations. I'm assuming you paused it. I'm assuming you tried it on your own. You may have run into some issues with these. I'm going to look at the first one here. I'm going to use the elimination method or the addition method. I see that the x's are lined up and the y's are lined up. So I'm going to add straight down the line. -7x plus 7x is 0. So far that works out really well. And y minus y is 0, which is weird because now we have 0 on the left side of the equal sign. Equals 9 plus 2 is 11. So I get 0 equals 11. which is a problem because 0 doesn't equal 11. That's wrong. This is a special system. So these two are both special systems. And I'm going to show you what is going on with this and why we get the result we do. When you use the elimination method, you get 0 equals 11. If you use the substitution method, you'd also get a weird situation that doesn't quite work well. And here's why. If you graph these two equations, they're parallel lines. These two equations are parallel. They never intersect. There is no value for x and y that they share. If they cross, if they intersect, there's one xy, there's one coordinate where they share that point, where they share an x and a y value. This one doesn't. It's parallel. And you can show that either by trying to solve it and showing that it's a contradiction, that it doesn't work. 0 equals 11 is wrong. Or the other method is to see if they're parallel. We said in chapter 3, I believe, or chapter 4, it must have been chapter 4, that two lines are parallel if they have the same slope. So if you look at this first equation here, if you got y by itself, if you added 7x to both sides, the slope would be 7. If you if you got y by itself here, you'd also get that the slope was 7. So if you can show that the two equations have the same slope, you've shown that the system is what's called inconsistent. You've shown that there are no solutions. So there's no solution to this system at all. They're parallel lines, they never intersect, there's no solution. We call that an inconsistent system. The second one here, because y is already by itself, this one lends itself well to the substitution method. So if you replace y with 2x plus 1, what you'd end up with is 2x minus 2x. We distribute that minus sign through. So you have 2x minus 1 plus 1. And 2x minus 1 plus 1 equals 0. So you'd end up that 0 equals 0. So this is always true. 0 always equals 0. If you subtracted 2x from both sides and used the elimination method, you'd end up with the same thing. You'd end up with 0 equals 0. And that's fine. 0 does equal 0. That's always true. If you graph these two equations, it looks like this. And it doesn't look like I have two equations on there, but they're the exact same line. You've got y equals 2x plus 1. If you got y by itself here, if you added y to both sides, you'd also get 2x plus 1 equals y. You'd get the exact same equation. These two equations will always intersect. They will always share points because they're the exact same thing. So it's like one line laying on top of another line. They intersect an infinite number of times. 0 always equals 0 when you solve it. And so we call this a dependent system, but there's an infinite number of solutions. They're always intersecting. So the three things that really could happen is you could get one solution. There's one spot where those two graphs intersect. There's one solution to that. You could get an inconsistent system where they never intersect. They're parallel lines. There's no solution. Or you could get a dependent set where it's the exact same line and there's an infinite number of solutions. You could pick an infinite number of x's and y's and it would work. Okay, I'm going to stop there. We'll look at inequalities in the next video.